Welcome back, Nature in Code. We're in chapter 4, and in the previous video we just developed this code here that allowed us to verify the prediction that an allele will go to fixation, a neutral allele will go to fixation with the probability that equals its frequency. And we tested different values here, but originally we had this 1 over 2n initial frequency, which is the initial frequency if the mutant allele exists in just a single copy in a diploid population of size n. And we saw indeed that the probability of this allele going to fixation is 1 over 2n. So now what I would like to do is I would like to understand how long that process takes. So if the allele does go to fixation, how many generations does this take on average? And we can just use this code here that we already developed. We already have pretty much everything in place. We just need to keep track of the number of generations. And so I'm going to do that. I'm going to create here a local variable called generations. This is my counter. I'm going to initialize this at 0. And so every generation, so every time we call this function here, next generation, I'm going to up this by 1. So generations equals generations plus 1. And so now this generations counter will tell me, from how many generations each simulation ran. And I want to keep track of the total number of generations in all the simulations that were successful in the sense that the A1 allele went to fixation. And then I can later divide this by the number of successful simulations. So I am going to define up here a new global variable that I'm going to call total generations. I'm going to initialize this at value 0. And now down here, if the simulation has been successful, so if the A1 allele has gone to fixation, I'm going to increase that value, total generations, by however many generations it took for the A1 allele to go to fixation, so plus generations in this particular case. Okay, so after everything is said and done, this total generations will have the total number of generations in all the simulations that were successful in the sense that the A1 allele has gone to fixation. How many are those? Well, this counter here, fixations of mutant, it gives us exactly that answer. So what I'm going to output down here is simply the total number of generations, okay, total generations divided by this fixations of mutant, which is the counter of the number of simulations. And now if I save that, and go back to my browser and reload this, then you can see the answer here is 418, 439, 360, and so on. This is pretty fast. I'm going to go back and increase the simulations counter here by a factor 10 to 100,000 just to get rid of the stochasticity, not get rid, but to reduce the stochasticity a little bit. I'm going to reload this. Now this is going to take a little longer, but once the answer comes up, you can see that it's 399. So this is practically 400. So I'm going to reload this again, and I don't expect it to be very different. It's 407. So it turns out if you open any population genetics textbooks, the answer is actually 4n. And this is indeed true. So I'm going to reload this again here. If you would do this over and over again, you would get very close to a value of 400, and so you can see we're here in just a few percentage points, and we're pretty close to 400. So the answer is 4n for how long it takes for a single mutant allele, a single neutral mutant allele, to go to fixation in a population of size n. And so that ends this video and also ends this chapter. So we've learned quite a bit. Fundamentally, we've learned that mutation generates genetic variation and that it counteracts the process of genetic drift, which acts to reduce genetic variation. And we've looked at what the likelihood is, the probability that a mutant allele will actually go to fixation, and how long this takes. And along the way, we learned some interesting new JavaScript concepts. So I hope this was informative, and I see you in the next video for Chapter 5. See you there.